Hello students, in this session, we will study the chapter on mixtures. Mixture problems appear in many real situations such as mixing liquids, combining grains, adjusting concentrations, or preparing solutions. The idea behind every mixture question is simple. When two or more components are combined, the total quantity of the mixture equals the sum of the individual quantities. Today, we will learn the basic mixture concept, ratio-based mixture calculation, and an introduction to the alligation rule. Each concept will be followed by a separate example slide for clarity. Let us begin. A mixture is formed when two or more components are combined. These components may be liquids, solids, or gases. If the components mix uniformly, the resulting concentration or ratio remains consistent throughout the mixture. The core idea is that the total equals the sum of the parts. If you know two of the three values, that is, first quantity, second quantity, or final mixture, you can easily calculate the third. Here is a simple illustration. Suppose you mix 2 liters of one liquid with 3 liters of another. The total mixture becomes 5 liters because the total equals the sum of the individual quantities. This basic idea is used in every mixture question. When two components are mixed, the final ratio is determined by comparing their volumes or weights after mixing. If component 1 is a units and component 2 is B units, the mixture ratio becomes a ratio B. This ratio helps calculate how much of each component is present inside the final mixture. This method works for liquids, grains, and even chemical solutions. Let us take an example. Suppose you mix 4 kilograms of rice of one type with 6 kilograms of rice of another type. Total mixture equals 10 kilograms. The ratio of the two types becomes 4:6. After simplification, it becomes 2:3. So for every 2 kilograms of the first type, there are 3 kilograms of the second type. Many mixture questions involve cost per kilogram or price per liter. In such problems, the total cost of the mixture equals the sum of costs of the individual components. If one component costs P rupees per unit and the other costs Q rupees per unit, the final cost of the mixture depends on both the quantities and the prices of each component. Let us understand with an example. You mix 3 kilograms of wheat costing 40 rupees per kilogram with 2 kilograms of wheat costing 60 rupees per kilogram. Total cost equals 3 multiplied by 40 plus 2 multiplied by 60, which equals 120 plus 120 equal to 240 rupees. Total quantity equals 5 kilograms. So the average price of the mixture equals 240 divided by 5, which equals 48 rupees per kilogram. Alligation is a special shortcut used for mixture questions where two components with different prices or concentrations are mixed to obtain a desired average price or concentration. Instead of doing long calculations, the alligation method directly gives the ratio in which two components must be mixed. The rule is ratio equals difference of high value and mean value, ratio difference of mean value and low value. Let us apply the alligation method. Suppose you want to mix a liquid containing 30% acid with water which contains 0% acid. The final mixture must contain 20% acid. High value equals 30, low value equals 0, mean value equals 20. Difference of high value and mean value equals 30 minus 20, which equals 10. Difference of mean value and low value equals 20 minus 0, which equals 20. Thus the ratio of water to acid solution becomes 10:20, which simplifies to 1:2. This means 1 part water must be mixed with 2 parts of the acid solution. Sometimes mixtures contain more than 2 components. The method remains the same: combine quantities and compare ratios. If the question involves 3 types of grains or 3 types of milk, the total mixture quantity equals the sum of all three quantities. From there, you can find individual shares or concentrations. Let us take an example. Suppose you mix 2 liters of one liquid, 3 liters of another liquid, and 5 liters of a third liquid. Total mixture equals 10 liters. The ratio of the 3 liquids becomes to ratio 3:5. This ratio can be used to calculate contribution or concentration for any required part of the mixture. Sometimes, a portion of a mixture is removed and replaced by another substance, usually water. This is known as a replacement process. In such problems, the concentration reduces gradually with each replacement. There is a standard formula used for repeated replacement which states remaining quantity equals original quantity multiplied by the value 1 minus removed quantity divided by original quantity raised to the power of number of replacements. Let us take a clear example. A container has 90 liters of a mixture of milk and water. You remove 18 liters of the mixture and replace it with water. After one replacement, the remaining mixture equals 90 multiplied by 1 minus 18 divided by 90, which equals 90 multiplied by 4/5, which equals 72 liters. If repeated again, the remaining mixture becomes 72 multiplied by 4/5, which equals 57.6 liters. This is how repeated replacement reduces concentration step by step. Here are some important rules to remember. 1. Total mixture equals sum of all components. 2. Ratio method is very helpful for mixture composition. 3. Average price or concentration equals total value divided by total quantity. 4. Alligation is a powerful shortcut for two-component mixtures. 5. Replacement formula is used when part of a mixture is removed and replaced multiple times. This completes a detailed discussion on mixtures. We learned basic mixture ideas, mixture ratios, value-based mixtures, alligation shortcut, multi-component mixtures, and the replacement formula. Practice each type of question to strengthen your understanding. Thank you for learning with me. Jai Hind.